All right, welcome to another installment of Math Basics, Mr. Besh. Now we take our knowledge of the stem and leaf graph and we go one step further. We talk about the double stem and leaf graph. You see, the double stem and leaf graph is great because it allows us to compare not one but two sets of data. For instance, the example that we have right here is talking about how tall football teams are. You got two teams, right? So the teams we got Team A on the left-hand side, and then we got Team B over here on the right. Now, if you look carefully, if I go through here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means there's going to be 11 players here for Team B. And when I go through and do the same thing here, 2, 4, 5, 6, 7, 8, 9, 10, 11. So I got 11 players over here for Team A as well. So now what happens is when you're using your stem and leaf graph, you are going to share. That's going to be the key element here. You are going to share. See, we're going to take what's in the stem in the center here because this is always going to be the first value of what we're going to have. So with this group that you all see here, okay, with this group that you see, the first row starts with a 6, the second row starts with a 7. So if I'm talking about Team A here, okay, here's what happens. When I'm talking about Team A, the smallest person on Team A, I would have to take my stem right here, which is 6, and put it together with the 7. Now that, ladies and gentlemen, this is not going to be 76. Remember, the stem always comes first, and then the leaf comes second. Team A and Team B are going to be mirror images of one another. These are reflections, all right? Whereas if you were trying to figure out the smallest person in Team B, again, you use the stem, and the number next to that's going to be 68. If you look at Team B doesn't have one. It actually has 3 68s, whereas Team A has 2 68s after the 67. If I ask a simple question, I said, hey, of these teams that you see here, which of the teams has the tallest player? Well, if we're talking about the tallest player here, and I look at what I have left, Team A's tallest player, remember, 7 and 3 makes 73 inches, and Team B's tallest player is 7 and a 2, which give me 72 inches. So I could clearly say that Team A has the taller of the players. All right. Now, the other thing that you want to note is you want to keep the data separate. We got a couple good questions by students that made some points. They said, "Well, wait a second. When you're using the data, do you treat 68 like it happened 5 times?" Or, and I said, "No, no, 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 no. What happens is 68 happens on Team B right here 3 times, but 68 only happens on Team A twice. So when you're writing your data, you're going to do 2 separate data. So over here for Team B, you're going to write them down. You're going to be like 68, 68." 68, the next one's 70, and dot 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 write your, and then when you do Team A, you're going to be 67, 68, 68. Because what's great about the stem and leaf graph is what I'm able to do now is now I'm able to say, hey, what's the mode of Team B? Then I'm like, hey, what's the mode of Team A? And then I could ask questions about crossing the graphs and going back and forth saying, well, what's the difference between, say, the first quartile of Team A and the mode of Team B? And now what you have is you have totally 2 sets of different data that you can use and you can share and you can go back and forth. So it's pretty neat. For as simple as something looks like this, there's a lot of good questions that we can ask about that. So if you got any questions, let me know. That's the double stem and leaf, folks. I hope you found this both helpful and informative.